All right, so welcome to this morning's session. It's a continuation on session 7 on indices or index numbers. So the other time I think on Monday, we started with understanding what index numbers are. We saw how we did compute index numbers, and well, we've gotten to the point where if we are interested in lumping up the index number or computing the index number for a group of commodities or more than one commodity. So for instance, unlike the case where we saw an index relative where you can have maybe a number of commodities where you end up selecting one and finding its index number or wanting to investigate what is happening with regards to change in price or quantity. In the case of indices for more than one variable, we seek to put together all the variables and actually compute one composite index number for them. And actually, that is what is the norm in real life situations. Oftentimes, we don't find inflation figure for only tomatoes, inflation for only onions, inflation for only maybe pepper. They are all put together, and a general bulk representation of what the inflation state or state of inflation is just presented out to us. So oftentimes they refer to it as a basket of goods. So we can, worst case would be to, let's just take vegetables, and then you lump up all vegetables, at least those that are very common, those that are most used on the market. And we put all of them together and find one composite index number for them. And then that becomes an expression to say that, okay, so for vegetables, this is the rate of inflation, for cars and that kind of stuff. But oftentimes we don't even get that luxury. It is mostly just presented for everything. So there are two methods that we are going to use for computing the index numbers for more than one variable. The first is the mean or average relative index, and the second is the simple aggregate relative index. For the mean relative index at a certain period, the expression says that we compute the index numbers or the index number of each item, and then when we are done, we take the average of all the index numbers put together. So if you have, let's say, 4 commodities, we will take the individual index number of each of the commodity, and then we will now sum all those index numbers and then take an average of them. That is the mean relative index. For the simple aggregate relative index, what it seeks to do is, rather than going ahead to first compute the index numbers before taking the average, it says to sum the actual values. So sum all the values at the current period, divided by the sum of all the values, all the base values, the respective base values, and then multiply by 100, and it gives you a composite index number. So please, let's get into it and see it. So let's assume this table here. We have 2013, 2014, and 2015. Assuming that 2013 is the base year, these are the values available. So in 2014, these are the prices of the commodities, coffee, tea, and hot chocolate. In 2015, these are the values. Now, in using the relative mean index, what this means is that we first have to find the index number for each year. So supposing we want to compare 2014 to 2013, which is the base year, we first need to find the index number of the various commodities. So we take the first one, which is tea, and we have 62 over 55 times 100. It gives us its index number. We do the same for tea, find the index number for tea, and again, find the index number for hot chocolate. In 2015, we do the exact same thing. We find the index number for all three. Okay. And having found the index number for all the three, this is how we compute the relative mean index. So for 2014, we sum the index number or the index numbers of each individual item. So this is for coffee, this is for tea, and this is for hot chocolate. Now, because there were 3 of them, we sum these 3 and divide by 3. And so that average index, or the average number we have, is the index, the mean relative index, or the relative mean index. The same applies to 2015. So here, this is the index number for coffee, this is the index number for tea, and this is the index number for hot chocolate. We sum them up and we divide by 3, and it gives us the index number, or the relative mean index. In the case of the relative aggregate, sorry guys. In the case of the simple aggregate relative index, rather than going ahead to find the the index numbers, what we seek to do here is to aggregate all the values, okay? Aggregate the current values, the PNs, and then aggregate the base values, the respective base values, and multiply by 100, and it gives you a composite value. So here, for 2014, this is PN for coffee, this is PN for tea, this is PN for hot chocolate. We will sum all 3. And then for the base year, this is PO for coffee, PO for tea, PO for hot chocolate. We will sum it as well. So here you see that this is the sum of all the PN values for the respective commodities, and then the sum for all of them again, and we multiply by 100, and then it gives us the simple aggregate relative index. Okay, so if we are also interested in 2015, we do the exact same thing. You sum all the current prices as at 2015, and you divide by the sum of the prices at the base period, which is 2013. You multiply by 100, and we have this. So if you go back to the formula, it says that summation where I goes from 1 to k. So I goes from 1 to k. It means that it starts from the first commodity to whatever number of commodities. So if we assume we have k number of commodities, then there can be as many as possible. Okay, so here we are summing all the VNIs. VNI is the maybe the value. Okay, this time around it's not the index, but it is the value for each current period. So and I we know starts from 1 to k. Okay, all divided by the VO, which is the volume at the base period. Okay, so all the values at the base period, the sum of all base values, and then the sum of all current values. Okay. And if you look at the case of the relative mean, the mean relative index, it is the sum where I goes from 1 to k, the index, okay, the index of all the values, okay, and I over k, and k represents the number of indices, or yes, index numbers that we sum. All right, so we have seen the relative mean index and then the simple aggregate relative index. However, these methods have certain weaknesses that do not necessarily give an appropriate picture of what the situation is. Now, suppose that the price of a loaf of bread was 2 cedi in year 1 and 240 in year 2. Also, the price of a ton of butter is 2 cedi, 2,800 in year 1 and 3,000 in year 2. You notice that yes, we would put these information together, right? However, it doesn't really tell the actual change. Now, between 2,800 and 3,000, that's just a 200 cedis change. 240 and 2 cedis is like a 40 pesos change. Now, a change as low as 40 pesos and a change as huge as 200 cedis do not, what's it called? It doesn't really, they are not the same. Now, suppose that we ignore the change in the price of bread and we compute this thing. Look at, you see that the contribution of the change in the price of bread is so marginal. This is 107.15 and this is 107.14. So the contribution of the change in the price of bread is just 0.01, right? Meanwhile, we are accounting for this in the index. So you may think that bread, the change in bread is actually contributing something. It's practically contributing nothing. So the index values are almost the same, implying that butter has virtually, what's it called? It virtually has no influence, okay, on the composite index, okay? And in the case of the mean as well, you would see that sometimes a commodity would have a very high index. Okay, again, you see that, for instance, now let's take the individual stuff. We have 2.4/2. This is a 20 percentage point increase. And if you have this again, you would have 107.4. Now, here is a 20 percentage points. This is a 7.14 percentage point increase. So indeed, there's a huge jump in the price of bread, but we are not actually seeing it. And then, whereas there is a marginal or kind of not too huge jump in the price of butter, yet that's where our emphasis is going to be. So you would see that it could give certain deceptive, information or analysis of the situation. Now, when we combine the two, now everything comes to 113.57, which hides the actual what is actually being the truth on the ground, for lack of a better word, anyway. So in this case, we do not see a fair contribution, or we are unable to account for the contribution of each of the items in the index that is presented, or the index number that is presented. Another situation could also be the case of a mixture of units. Okay, some items are probably measured in kilograms, some in milligrams, some in grams, some in liters, and in some other form, some in baskets, some in tons. All these are very, very important. Now, if you have to let's say effectively compare all of these things, then the first thing is you must seek to try to convert all of them into one uniform, unit or SI units. And so, for instance, if it's kilogram, then even if it's a basket of tomatoes or a ton of oil or whatever it is, you would have to try and convert all of them into one unit that gives them all the same, the same level or same foundation for comparison. However, if you are unable to do that, then putting different measuring units together is like comparing apples and oranges, which will not be a fair comparison. Like you have 5,000 kilograms and then 1,000 grams. That is not a fair comparison of it. So it gives it additional work. So imagine I give you a question and I ask you to either use the relative mean index or the simple mean index or the simple aggregate index. And then I intentionally put some in tons, some in milligrams, some in kilograms, some in baskets. You would first have to seek to convert all of them. Now, the more the number or as many commodities we have to evaluate, the more cumbersome or difficult the combination, the computation becomes. So we want to find a way in which we can, account for these variations in the commodities. And one of the ways in doing that is to include importance weights. Okay, and we attach weights to some of. So for instance, if we take the case of the sugar and the bread and the butter, where in actual sense it is bread that is actually experiencing a higher price change, a higher change in index compared to butter, although the values seem deceptive, 200 cedis and then 40 pesos. In these instances, if we can attach something like weights, importance weights, then the importance weights will be added to instances where we feel or we see that significant differences exist and we need to account for these differences. So, so just giving an example, if you have something that is sold at a price of 2 CD and then you have a quantity of 20,000 being bought, and something that is being sold at a price of 1,000 CDs and then only 2 is being bought, like comparing water and gold. Even a bucket of water is still less than 1 CD. So someone can buy as many buckets of water in a day or in a week or something. However, if you're selling gold, a piece of gold, I'm not sure, but just for example, you can have a piece of gold for 1,000 CDs, and can that same person afford 20,000 units of gold in a week? No, maybe 2 in a month or something. So in these instances, there are clear variations as a result of the price and the quantities being divided. So we need to attach importance with one seems to be very important than the other, and so this is why it is less of it is bought and more of it is bought data sets. So these, in computing the weighted indices, what we knew at first as the mean or the average relative index will now become weighted mean average relative index, where we say that in the first instance, all we did was to first calculate the index numbers and divide by the number of index numbers. Now we are saying that for each index number, we multiply it with a certain weight that has been determined, or the respective weights determined for each relative index, and then divide it by the sum of the weights. Okay, all right. Then in the case of our aggregate index, or the simple aggregate index, now it will become weighted aggregate index, where in the first instance, all we did was to take the sum of all the values at the current period divided by the sum of all the values at the base period. In this instance, before we take the sum, each value at every period will be multiplied by the respective weight, okay, and taking the sum. And then we'll also come to the base values, multiply each of the base values by the respective weight and take the sum. So the sum of the current values over the base values would have now incorporated the important weights, and now we multiply by 100. So let's get into it and see. All right, so this time around, you see year 1 with the prices, and these are the commodities A, B, C, and D. And then now we have year 2, which is our current period, and these are the values, okay, as a year 2. Now, in addition to just the data of the prices at the base and current periods, we have importance weights having been attached to them, okay? So in the first place, to compute your weighted mean price index, what it says is, first, like we did, compute the, what's it called? So for A, compute the index numbers for each of the commodities. So for A, we would have the current price, which is 24, divided by 20 times 100, okay? And then for B, you compute 51 over 55 times 100. For C, you have 84 over 63 times 100. And then for D, we have 34 over 28 times 100. Now, when you are done and have computed these values, whatever that you have, let's say this is 107, let's say this is 11, maybe 90, I'm just giving fictitious values, and probably this is 134, and maybe this is 117. I'm just giving some examples. Now, initially, what we did was to sum these values, okay, these index numbers, and divide by the number of index numbers. That's like taking the mean. Now, we will multiply each of the index numbers with the respective weight. So first, you take 107 times 4, okay, plus, again, then the next one would be 190 something times, sorry, so the first one will be times 6, and the next one will be times 4, and then the other one would now be times 1, and the last one, which is 117, will be times 8. When you are done, okay, you divide by the sum of the weights. So please have that in mind. So having multiplied this and had this, you will now divide by the sum of the weights. So the weights here, 6 plus 4 is 10, 8 plus 1 is 9, so 10 plus 9 is 19, okay? All right. Now, in the case of the weighted aggregate price index, what we initially knew as a simple aggregate index. Initially, we summed all of these, so we would have just done 24 plus 51 plus 84 plus 34, all divided by 20 plus 55 plus 63 plus 28, okay? But now, we are saying that before we just sum all of them, we multiply each of these values, okay, by their respective weights. So you now first have to do 24 times 6 plus 51 times 4, okay, plus 84 times 1 plus 34 times 8. So this is multiplying all the current price values by the respective weights. And you divide again by, take the base price values and multiply them as well with the respective weights. So here you're going to do 20 times 6, okay, 55 times 4, 63 times 1, and then 28 times 8. And when you're done, you multiply everything by 100, and that would give you an index number that accounts for the different contributions of each of the commodities. Is are we okay? Do we understand what we're doing? Is are we okay? All right.
Yes, sir. Yes, sir.
All right.
Yes, sir.
Okay. All right.
Sir, please can you go over?
No, I can go over. All right. All right. So this is what we're talking about here. So in the first instance, when we are computing the index, the mean relative index, what it says is first compute the index numbers. Okay, so you have, so we take the first one here. We take, so for the weighted mean price index, we first take the index numbers, just like we have always known, just do PN over PO. Okay, and then so here, this is like just finding the index number of each of the commodities. Very simple. We have all done this. Everyone can do this. And when you are done, take each of these values, each of the index numbers, and multiply it by the respective weights. So we take 120, we multiply it by the weight of 6. We take 92.73, we multiply it by the weight of 4. 133.33, we multiply it by the weight of 1. And then for the last one, which is 121.43, we multiply by its weight of 8. When you are done, sum all of these. Okay, the output or from multiplying the index numbers by the weights, sum them. When we sum them, we have 2195.69. So 2195.69. When you are done, divide this by the sum of the weights. And so if you sum these weights, we have 19. Okay, so this value divided by 19 is what gives us the 115.56. All right. And then the next one, which is the weighted aggregate index, okay, which used to be the simple aggregated index. Now, initially, all we did was to take all the current prices or the PNIs, sum them, and divide by all the base values, okay, the sum of all the base values. But now, before we do that, we're saying that multiply each of the current price values by the respective weights. So we take, so if we come here, so this is the table here, we take this value, this is the current price. You remember it is PN over PO. Now we are taking the sum of all the PN, so we'll now have PNI, and here this is going to be sum of all POI. I mean, where I goes from 1 to K. I goes from 1 to K, meaning that I goes from the first commodity to whatever number of commodities we have. In our case, there are 4. So here we would say I goes from 1 to 4 in that case. All right, so here we multiply 6 by 24. Then 4 times 51, 1 times 84, 8 times. So these are the weights. These are the weights. And these are their respective Pn values. 24, 51, 84, 34. So you multiply these and you get these values. So when we sum these values, we have 704. And we'll now go to the base values as well. Take each of the base values, multiply it by their respective weight. So these are the weights again, being multiplied by the base values. And these are the outputs, and we have a total of this. So we now have a sum of all the current price values multiplied by their weights. And this also is the sum of all the base period values multiplied by their weights. So you just do your 704 over 627 multiplied by 100, and it gives you this index number. Okay, and so this is 122.20. And so this index truly reflects the differences or the variations that exist in the the commodities. Okay. All right, so there are 2 other very special indices. Now, they are also weighted indices anyway, but there are instances where we are unable to generate weights. We don't have weights. We can't generate weights for the commodities. Because coming out with the weights also is quite a cumbersome process, computing the weights. So there is a simpler way where we have 2 indices. One we refer to as the Laspaye indices, and then the second one we refer to as the Paché indices. So first, let's focus on the Laspaye indices. It's a French borrowed word. The Laspaye indices is also referred to as the base weighted index. So please let this give you a clue. Base weighted, this word base. Now, for the Laspaye index, it uses the values at the base time period as the weights. Okay, the values, so remember, that's why it is called the base weighted index. It uses the values at the base time period as the weights. So this is just how it works. It's just like a crisscross something. When you are finding the Laspaye price index, okay, you're finding the Laspaye price index, then the base quantities will be used as the weights. Okay, so please think about it. When you are finding the Laspaye, okay, some will call it Laspaye price index, okay, the base quantity is the weight. Okay, and when you are finding the same Laspaye quantity index, okay, who can tell me what will be the weight now? Who can tell me what will be the weight?
The base.
The base what?
The base
Prices.
Exactly. The base prices would be used as the weight. That's it. That's just simple. That's why it is called the base weighted index. So if you are finding the price index, then the respective base quantities would be the weights. If you're finding the quantity index, then the respective base prices would be the weight. So let's try an example. So let's say we have 2 items, A and B. We have the base price and then the current price, the base quantity and the current quantity. If we are finding the Laspaye price index, what this is saying is now we will use the base quantity as the weight. So we first take, if because it's price index, we need the current price. So it's going to be the current price, which is 15 times its respective base quantity, plus the second one is 25 times the respective base quantity, divided by, now we move to the base quantity because you remember the formula is Pn over Po, right? So this is the base price, which is 10 times the respective base quantity, which is 95, plus 20 times the respective base quantity. When you're done, you multiply by 100. It gives you your stuff. Okay. So this is for the last pay price index. If you're finding the last pay quantity index, we do the reverse. Now, for quantity index, let's clean it. So last pay quantity index, we know that to find the quantity index, it is the current quantity over the base quantity. Okay, but we are saying that here, because it's quantity, then now we will use the base price to be the weights. Okay, so here we would come and say, so this is the current quantity. We would have 100 times, what is its respective base price? It is 10 plus. And the next one is 2, which is the current quantity, and then the respective base price is 20. We divide by, now we'll take the base quantity. The base quantity, the first one is 95, and then the respective base price is 10. So, and then the other one is 4 and the respective stuff. So here you do see that, look, the base values do not change, whatever base values you use at the top. So the only thing you just need to understand that if it's for quantity index, it is current quantity over base quantity. If it's price, current price over base price. Once you're able to identify the fact that if it's quantity, we use base price. If it is price, we use base quantity. We're done. That's all. Okay. All right. Now let's get to the second one. Now, the Pache index is the reverse of the last Pache index. So the Pache index is also called the current weighted indices. Use this again as an indicator. Pache is current weighted index. Last Pache is base weighted index. Okay, so for this one, here we are assuming that the current price and quantity would be used as the weights. So if you are computing a Pache price index, which we know is PN over PO generally, then we will use the current quantity as the weights. But if you're computing the Pache quantity index, which you know is QN over Q naught, then we would use the current price, okay, as the weights. Are we okay? Is everyone okay? Perfect. All right, so we can go back to this point here and again compute the Pache price index. So let's say we have the Pache price index here. So the first thing we want to do is, because it's Pache price index, we know price index is PN over what's it called, the PO, isn't it? Now, here it is a current weighted index, so we will need the current quantity, okay, to find to be the weights. So let's start. So here, this is going to be, the first one is the current price for item A is 15. Its current quantity is 100 plus. Then the second current price or current for item B is 25, and the current stuff is 2. Okay, all over. Now we need the base price. So the base price is 10 times again the current quantity, which is 100, plus base price is 20 times 2, all times 100. Okay, if you're finding the Pache quantity index, then we know that for quantity index, it is QN over Q naught, okay, generally, from a general perspective. But now we will require the current price as the weights. Okay, so let's find, this is the current quantity, this is the current price. So we have 100 times 15, okay, plus 2 times 25. See it, it's just very simple. Then again, we have the base quantity, which is 95 times 15, plus the next one is 4 times 25. Then we multiply by 100. You're done. This will be the Pache quantity index. Okay, so there's a full-blown question here, which has 4 items, year 1, year 2, and then the number of units. So number of units, please, I hope you have it, that is quantity, and the price per unit would be this. So let's assume that year one is the base period or the base time. Okay, so if year 1 is the base time, I can ask you to find the base weighted price and quantity index, and you can also find the current weighted price and quantity index. Everyone can do this. This is straightforward. So if we are looking at the base weighted price index, we know first, just write price index is PN over PO. And because we are looking at the base weighted, so we will need the base quantity to be the weights. You are done. So this would be the last by A for base. Now, if you're doing it for base quantity index, we know it is the current quantity over the base quantity originally as then the weight is now going to be the base weight, the base price, and then the base price being used as the weight. If you're looking at the current weighted indices, which is the per share price index, we know again for price is Pn over P naught. Because it's current weighted, we'll use the current quantity. Okay, and if you're looking at the per share quantity index, for a start, we know it is the current quantity over the base quantity. And because we are looking at the current weight, we will need the current price as the weight, and you're done. So this is expressed here as this. So for the last price index, we have this. The quantity index, we have that. For the per share index, price index, we have this. And the per share quantity index, we have that. Okay. This is very easy. It's just easy stuff. You just need to find your way around it and, you know how to work your way around. Yeah. So please, any questions so far so we can move to the next session? Any questions? All right, perfect. Everyone is fine. So I can close dockets on this. So I think this is session 8. And this is where we are actually getting into more business stuff in the course. So obviously, I am not sure we'll be able to end everything, but we'll do as much as we can. So we are beginning what we call financial mathematics, okay, financial math, and we'll be looking at several concepts. Today, we will be mainly understanding what we call cash flows, okay, and then get to understand what present values, what future values are, and then look at the different streams of cash flows, okay, where we would have the uniform cash flows, the arithmetic gradient cash flows, the geometric gradient cash flows, and then cash flows in perpetuity. So that's all we want to do today. And then when we have these different types of cash flows, how are we able to determine their future equivalent and then the present equivalent? Now, this is a decision that we all, even as individuals, we make all the time. Businesses also make these kind of decisions, and it helps us to make certain decisions that affect our positions in the future and in the present. So let's see if I can understand this, but let's start with a certain preamble. On the average, if you were given, let's say, $100,000 today, and you do not have any plan immediately for the money, the first thing that would come into your mind is to find a bank to keep that money. Now, if you found a good bank and you kept your money, you would be interested in first investing the money to keep it safe, such that when you are ready to do something significant with the money, maybe you start a business, you could go into maybe building a school or probably starting real estate. I don't know what you may want to do. But for now, you're in school, so you can't really put your mind to anything you want to do. Rather than blowing the money, maybe buying a car in school and be going from club to club and doing all sort of stuff, you would rather keep the money somewhere. Or maybe even after school, put up a house and start forging the future in a very sound ground. The bank will tell you we have an interest rate of, let's say, 10%. So when you keep your money with us for 2 years, right now you're in level 200. So by the time you are done in school or you're out of school in the next 2 years, you should calculate how much 10% would be. What you're doing is you have a certain sum today, okay? And per that rate of change or per that interest rate, you are interested in finding out how much that 10% or how much your $100,000 would accumulate to become after 2 years. So maybe you go to EcoBank and they give you that. I say, okay, hold on, just keep the money in my account before I take your investment. Then you move from EcoBank and you go to maybe Consolidated Bank. You talk to them. If I have $100,000 and I want to invest in a certain investment option, you have, how much would you give me? Someone will say, okay, we have an investment package for 10.5%. You go to another bank, it says, we'll give you 12%. Some will say we'll give you 13%. What you are trying to do is for each of these options, you want to maximize your return after 2 years. And so you would also be interested in you finding out how much your your $100,000 would become after 2 years. The bank that gives you the highest possible return becomes the bank you are going to do your investments with. Okay, and so in trying to understand what a certain sum of money would become today or tomorrow from today, you are actually traveling on the time value of money. Again, if you have some years back, you could buy a ball of kenke for 50 pesos. Does anyone know where we can get a ball of kenke for 50 pesos again in Accra? Even in my village, a ball of kenke is not 50 pesos. So what 1 cedi would do, or what 50 pesos could do 5 years ago, it isn't able to do that again today. And so you can again also be in a future period and be interested in what the current sum of a certain money, of a certain amount will be. Think about it. If your father, if I promise to give you, let's say, get a first class at the end of your program, and then I'll give you 10,000 cedis. All right, so maybe you already see your weight and you know that, oh, do for first class, there you get it's not a problem. You just have to pass business maths very well and pass quantity methods very well, all the other courses as well, and then move. But now you need money to do something very important, and you are sure that I would give you the 10,000 cedis once you get the first class when you complete. So you can go to a bank and find out what will be the equivalent of 10,000 cedis today at your rates of loans or at your interest rate. So what we are trying to say is you have a certain future sum of 10,000. You would have 10,000 in 2 years, but you want to know the equivalent of 10,000 here today, such that you can take some money in lieu of that 10,000 cedis. And by the time you would probably graduate and make your first class, once you receive your 10,000, you can. And so we are interested in finding out the differences, okay, what a certain sum of money would be today and what it could be tomorrow. All right, so these are the preambles. So the first thing we want to look out for is what we call a cash flow diagram. A cash flow diagram is just a tool we use to represent the inflow and outflow of cash, okay? And when we say inflow represents money coming into your coffers, and outflow represents money leaving your coffers. And so if you're a business or an individual, there are certain times you part with money and there are certain times you receive money. Whenever you are parting with money, that is an outflow. Whenever you're receiving money, that is an inflow. Now, what you find here, this thing here, in our days in primary school, we'll call it the number line, right? Today, we are referring to it as the time value of money. Okay? Now, on the time value of money, the various points you find are different time stamps or different time periods. Okay, so we always would start from period 0. Period 0 always refers to today, the very moment you are in now. And period 1 will be the next period. So if it's a year, then this is 1 year from today. This is 2 years from today. If it's a week, and this is 1 week from today, 2 weeks. If it's a month from today, in that order. Okay, so whatever number of months that we have. Now, again, on these timestamps or these points, period 0 is often the beginning period. Okay, now look at it like between 0 and 1, we'll refer to it as period 1. Between 1 and 2, we refer to it as period 2, period 3, in that order. Okay, so this here is the beginning of period 1, and this is the end of period 1. I believe everyone understands. However, this again, although being the end of period 1, it also marks the beginning of period 2. Okay, because this is period 2, period 1. The gap between 0 and 1 is period 1, and the gap between 1 and 2 is period 2. So this point here is the beginning of period 1, and this is the end of period 1. The end of period 1 marks the beginning of period 2. And so it goes in that order. So this is the beginning of period, this is the end of period 4, but the beginning of period 5, in that order. Okay, so we go on and on and on. So this is what has been explained here. Between this point and this point, we have period 1, this point and this point, period 2, in that order, to whatever number of periods we have. Now, we use arrows to represent the outflows and then the inflows. So if you find an arrow pointing up, that is an inflow. If you see an arrow pointing out or down, okay, that is an outflow. So this is out, this is in. Think about it like, I don't know if you guys are doing macroeconomics or you've done macroeconomics already. There's something we call a leakage and injection, right? So if you have a tire, let's say a bicycle tire, when you fix the pump and you pump air into it, it inflates the tire. So you are injecting air into maybe the tube of the tire or something. However, if you take off the knob and the air seeps out of the tube, then the air is leaking, or maybe there's a puncture or something somewhere, there's a hole that enters into the tube, you'll find the air leaking out. So that is the concept. Now, the longer the arrow, the length of the arrow, it means the bigger the amount. So here, if I have an amount, say 100, this is going to be, if I have an amount like 1,000, 1,000 will surely be higher than, what's it called, 100. Okay, so the longer the length of the arrow, the higher the amount, and then the shorter, the smaller the amount. Okay. Then what we have here is a cash flow table, which oftentimes no one teaches a cash flow tables. It's so obvious. So the cash flow table just gives you a tabular representation of the periods and then the respective cash flows in the period. So for instance, you have a company over the years, over a 7-year period, have had these cash flows. So in year 1, it has, what's it called? 100 million going out, 10 million going out, and in year 3, it has 10 million coming in, 50 million, 40 million, 40 million, and then 50 million. Now, says when money is paid out or received in the beginning of the year, and then, all right, so again, let me introduce you to one more thing. So, guys, in real life situations, you would agree with me that there are certain times cash flows occur at the beginning of a period or they occur at the end of the period. Sometimes happens. For instance, if there are some workers who are paid at the end of each month, there are others who are paid at the beginning of the month. Now, for instance, if you go for a loan from the bank often takes the deductions or makes the deduction at the beginning of every month. Whereas your salaries hit your accounts at the end of the month. Now, you remember I have said that if you take the periods, this is the beginning of the period, and this is the end of period 1. However, this again is the beginning of period 2, okay, although it's still the end of period 1. So for instance, if I have, let's say, if I have this, let's say I have the time value of money like this is 0, this is 1, this is 2, this is 3, this is 4, and let's say this is 5, this is 6, 6-year period. If I am assuming that the monies are paid at the beginning of the period, so let's say that you receive your salaries at the beginning of the month, right? Let's start with the instance where you receive the salaries at the beginning of the month. This is the beginning, so money hits your account at the beginning, right? So for, let's say for the first, let's assume it's monthly, so 6 months. So for every month, your salary can the same. So I'm trying to make them as equal as possible. So at the beginning of every month, this is how we represent it. So you notice that there wouldn't be anything happening here. You will see that you have received your 1, 2, 3, 4, 5, 6 payments of salaries. However, if we assume that your salary or the income will be hitting your account at the end of the month, okay, then at the end of the period, it will start from here. Guys, please, are we getting the drift? Okay, so all right, guys, sorry about that. I got kicked out. All right, please, can you see? Can we all see what's on the screen? Hello?
Yes.
Yes, sir.
All right.
Yes, sir. No, now we can hear you.
All right, perfect. All right. So if we are being paid at the end of the period, then you will notice that your arrows will start from 1, 2, 3 in that order up to the last period. But if you're being paid at the beginning, then it starts from 0 because this is the beginning of the period and this is the end of period 1. But this end is still the same as the beginning of period 2 in that order. So please take note of these variations, okay? So it says that depict the cash flows of a company, okay, on the cash flow diagram. So let it means like show this cash flow, okay? And in showing this cash flow, please show us when money is paid out or received at the beginning of the period and when money is also being paid out at the end of the period. All right, so in the case where money is paid at the beginning of the period, you'll see the first cash flow is 100 million, which is negative. Second is negative 10 million. These are outflows. So these are monies leaving the bank's coffers or the company's coffers. And all these are inflows. The positives are all inflows. So here, the first one, so this is at the beginning, this at the beginning, it's at the beginning in the order. So you notice that there's nothing in the sense here. But yes, if you count the bars, you would have had 7 installments. And if it's at the end, then we are not going to start from 0, we'll start from 1, okay, in the order. And then we will end in 7 on the number 7. All right, so just have that at the back of your mind so that you are not confused at any point. So then we have stuff about interest rates and interest. So previous years, I noticed we spend a lot of time trying to do all the provings and everything to get. At the end of the day, we are not even really interested in it. It's you gather your students and you give them a question to prove the interest rate, and it's like, what kind of evil guy are you, man? So today we're just going to walk through it, but we're not going to put emphasis on the proofs and everything. Thomas, you have your hand raised.
Yes, please.
Yes, please. We go back.
Doc, please, I want to ask if we have a formula for time value.
What formula? Well, we haven't started doing anything. All I've done is just to show you how we represent cash flows, okay? And then to get you understand what a cash flow is, okay?
Okay, sir.
All right,
Okay,
so we'll get into it.
All right, thank you.
All right, so what are interests and interest rates? Now, oftentimes when you are engaged in any activity with maybe some cash flows or something, for whatever reasons, the world has arrived at the point where nothing actually goes scot-free and nothing is done really free. So oftentimes there's always a price to pay for whatever financial transaction that you engage. Either you are paying an interest, or there is a more wicked brother of interest called depreciation or inflation. It is why I find it very difficult paying monies. In fact, when you teach a course like this and you get to learn stuff about financial math, you find it difficult to make an investment. So guys, let me ask you a simple question, okay? So the current rate of inflation in Ghana is almost 7%. I'm not too sure, last time I checked. So if you were investing in a fixed deposit account that takes your money for 6 months, okay, and gives you, let's even say, I don't know how many banks would even give fixed deposits, but let's say on average they give like 6% after 6 months. What is the interest on your investment? Inflation is 7%. Then interest on the fixed deposit is 6%. What is the return? How much in percentage terms? How much are you getting on your investment?
-1.
You're getting -1. So you are actually seated here telling everyone, Charlie, I get some money, I invest more. Charlie, me, I be smart guy. I invest my money, I invest my money. Your money is a sitting duck, and you are losing the money every single day that the money rests in the bank's account. Do you get it? But we don't see it because, so that is the part that even hurts me the most. You talk to an average Ghanaian and they go like, oh, you have money, go and buy a treasury bill. How much is the treasury bill now at the moment? Has anyone checked how much the treasury bill is at the moment? Even the last time the government was releasing its own funds out of treasury bill. Of course, the treasury bill is the way in which the government uses to borrow from us, the public. Now, so if the treasury bill is giving you, let's say, even 7%, if you compare it with the rate of inflation, by the time you take your money, prices of goods and services, all the things that you probably are going to use your money for, have risen so high that your money comes out and then the value of your money has fallen. So yes, at the end of the day, the bank will tell you, okay, so you invested 100 cedis and we said we'll give you 6%. So you've gotten 6 cedis, so they'll give you 106. But the rate of inflation would be said that, well, that same thing, if before you invest in your money, a bag of cement was 7 cedis, was 100 cedis, I just assuming, and inflation is 7%. By the time your money is coming out, the same bag of cement is now 107. So if you're investing the money to buy a bag of cement, you still even need to top up to buy a bag of cement, to buy that same bag of cement. So what the heck are you doing with your money in the bank? The only advantage the bank gives you is, well, it saves you from armed robbers. Apart from that, if you have some money and you have anything to do with it, put it in the business. Get something, do something with it immediately. Of course, lately, guys, there are, let's just digress a little bit. There's so many things. Let me give a few of you some, what's it called, ideas. If you need help, you can send emails, we can. Guys, try to read on some things we call drop shipping. I'm sure some of you have ideas about it. You can look for Amazon affiliates or Amazon affiliations. Now, a lot of us do these things today. Some of you are very smart. You have, let's say, 1,000 cedis. You don't want to put it in the bank. Talk to your friends. Charlie, I have some friend who brings this nice boxer shorts and everything and stuff. You go to Cantonment and you buy a pack of boxer shorts for 25 cedis. I can guarantee you, even if you come back and you sell it for 30 cedis to your friends, you haven't lost. By the time you are done with all that you have sold, if you, let's say, bought 10 packs and you have 5 cedis on them, you'd have gotten 50 cedis. And I can assure you, if you are able to sell all that within a month, there is no investment in Ghana at the moment that will give you 50 cedis a month. Even one's investment, at the end of the day, your money will be locked up. You won't get it. You only get a heart attack in life. So we do these things. Now, today, we all don't have time to actually do this kind of sales and everything here. So there are online, what's it called, sites that sells. I'm sure you've heard of AliExpress, okay? You've heard of Amazon, you've heard of, there are quite a number of them around. Just read on these concepts of drop shipping, and you can create your own website. And now creating a website it's nothing difficult. You can just go to YouTube and look for Wix. Okay, we use a website called Wix.com to create a website. Just say learning to create a website with Wix.com. It's super easy. It's drag and drop, no coding, nothing. You can create your own sales website and just put it online. Then the smart thing is you go to AliExpress, you just register as a dropshipping agent. When people want to buy stuff, there are a lot of people who do not have information. Okay, all you need to do is to have information. So you just need to talk, or read. Sometimes when you go onto AliExpress, you communicate with the the shops and tell them you're a dropshipping agent and this is your agency address, a card, and everything. Look, you can advertise their stuff in your country. It is very simple. You're only a middleman. Someone makes an order through you. You place the order for them. If the thing is, let's say, $5, you sell it for maybe $5.5 or $6. Everything the person buys, you get $1. If you're selling from the supplier, if the supplier sells the thing on average for, let's say, $5, he can give you a discount of, say, $4. So if you're selling it on $5, you're getting $2 on every stuff. Now, guys, I can assure you, Black Friday is coming next month. AliExpress also does their sales 11/11. There are people going to be buying a lot of stuff. I can assure you, within the space of 3 months, if you really put your adverts out there, just go to Facebook, you can boost your account, you can do anything. And not some of you have a lot of followers on Instagram and all this kind of stuff. Just, advertise your page, advertise the stuff, take pictures of the stuff, just download the pictures of the stuff on AliExpress and put it out there. Trust me, the ladies, they like buying stuff. Your friends, even the guys, Charlie, buy the stuff, tell them, okay, we'll take this number of this when we ship. That's all. If anyone is interested in all this kind of stuff, send me an email, or maybe we can talk, or if I have some time, we can give you a demonstration about how these things work out. You get to start working, okay? So you don't get up after school and be frustrated that everybody is not giving you a job, or whoever will come after him is not giving you a job. Life is very tough after school. Me, if I'm your father and I'm giving you money, by the time you get to when you go to level 100, I'll be giving you 1,000 cedis a month. When you get to 200, you reduce to 600. When you get to 300, you reduce to 300. If you get to level 400, you reduce to 100. By the time you're done with school, you are finished. You only get Banku in the house. All right, so enough of the talk. Let's, sorry, I should have paused it. We shouldn't have. All right, so interest rates come as the price you pay for whatever, for using someone's money or getting some money from somewhere to do some stuff. So For instance, we call in economic sense, they call it cost of capital. I don't know, or maybe if you have those of you who have done costing and or probably are writing those papers on CIMA, Chartered Institute of Management Accountants. In management accounting, we'll call this what's it called? Cost of capital. The cost equals the amount it costs you to actually acquire some capital for a business is oftentimes the interest. Okay. So we have the interest, which is the sum, okay, and then the interest rate is that percentage that is taken from. So when we sum all the tiny rates, the interest rates that you pay, maybe monthly, every month, let's say you pay interest of 20. When we put all together after the period, maybe for the period of period, this is your interest, okay? Then probably on the amount, if you have, let's say 200 cedis and you're supposed to be paying 10%, this 10% is what we call the interest rates, okay? So the simple interest for very short life, we usually have smaller rates. So for the types of interest, we have simple interest rates, and we also have the compound interest rates. And for compound interest, that's when your interest rates keeps increasing, compounding. It's a very wicked and horrible way of calculating interest rate. So we kind of like use this table to kind of try and understand differences between interest rates and then the compound interest. So the simple interest and then the compound interest. So for instance, in the first period, if you go for a loan today, okay, you are not charging the interest. So whatever the amount is at the beginning, at the end of that first period is still the same, okay? But when time changes hands and we move to the first period, your amount would be the same. This amount here is the same thing you have here. But this time, because a period has elapsed, we move from today to 1 year, interest will be calculated on, or maybe a month, interest will be calculated on. So your amount times the interest. So at the end of the period, what would be in your account would be your principal, which is the initial amount you deposited plus the interest. So look at it from the point where maybe if it's a savings, okay, if this is a savings, this is how it's going to be. If it's also a loan, this is how we're going to like use to compute your stuff. Okay, and so this amount becomes what you begin, or this is what you end period 1 with, and this becomes what you begin period 2 with. So now at the end of the second period, we just still calculate the interest on the principal, and so you're going to have the amount you have at the beginning, which is PI, plus your interest. So you're going to have your interest, your principal plus the interest plus the interest on the principal. So this is like interest having calculated twice. So we continue like that until we get to whatever number of periods. So you're going to have your P, your principal plus N. N is whatever number. So this is like period 4. Period. So this is all right. So you're going to have whatever number of periods. So the principal plus the number of times the interest was calculated. That's what we call the NPI. The same or similar logic applies to the compound interest, but for the compound interest, everything keeps compounding. You notice for compound is like when we start the period, you have a certain amount at the beginning. There is no interest started. So today you put the deposit, there's no interest, and so whatever this same value is what ends your stuff. So at the beginning of the second period, okay, remember that this is 1 period, okay, so from here to here, this is 1 period. This is the beginning of period 1, this is the end of period 1, but this same here is the beginning of period 2, okay? All right, so here at the beginning of period 2, 1 time has elapsed now, so 1 whole period has, and so this period is ending here at 1, so we need to compute. So interest would be computed. So now we are going to have what you had at the beginning plus what interest has been added onto it for you, and then you have this, okay? And so at the end period, whatever you have left, we bring it to the beginning, okay? Now the interest is calculated on what is left what is your new account balance. But if you come to the case of the simple interest, interest is only calculated on the initial amount. This is always the initial amount. But here, that's why we say it is compound interest. As the sum accumulates in your account, the interest is calculated on the accumulated amount, not the amount at the initial point. Okay, so then your new interest will now be this whole new sum, or the accumulation times the interest. So now at the end of the day, it is this whole, the new sum times the interest as what was at the beginning. So we add this and this, and so we put these two together and we have that. So it continues in that order until you're going to have this expression here, which you have P 1 plus I to whatever number of times the interest. So all this is the interest element. Okay, the same here that is approached, that is expressed here. Okay, P and I. The only difference here is that now here in this case we would have the interest being calculated on the accumulated sum, but in the case of simple interest, the interest is calculated on the initial sum. Okay, all right. So for simple interest, the total interest is the number of years times your what's it called, the principal times the interest. Okay, and I is the interest rate, P is the beginning amount, N is the time period. So if it's 5 years, it is that interest rate times what's it called, whatever the period is, times the number of years. Okay, for the compound interest, the interest is okay. So sorry. So the total amount for the simple interest period will be the original amount that you computed, the original amount that you obviously the initial amount plus the entire interest component. Okay, and for the case of the what's it called, compound interest, this gives us the whole interest component on the compounded amount minus the initial amount you kept in there. Okay, so for the total amount for the period N, we will have this expression here. Okay, all right. So again, so in the case of, we will base our interest mainly on the case of the compound interest. No one really does the simple interest thing, because the banks, well, they'll tell you they have something called reducing balance method. So as your balance is reducing, that is what they, and so whatever, I think the reverse is also the same. So maybe if they are charging 10 cedis every month, and you have a loan of 200, in using the reducing balance, after a year, they will deduct, you have 190. So now it is deducted from the 190. So here you have 180 in that order. So your amount is reducing fast. There are other people who have what we call the direct, there's a, I forgot, a straight line method or something. So they don't care. Every time the interest rate is calculated on the 200%, even if maybe the interest is 10%, 20, this is, they deduct 20, you're left to 180. Rather than calculating the 10% on this, they again still calculate it on this one and be accumulated. So your money goes so fast. So it's an normal, but lots of the banks will say they use the reducing balance method. So here, what we want to say is, now, if the total amount of period N equals this, then the assumption is that this can tell us your value, okay, the compounded value or the compounded sum in a future period. So let's say N is 5 years. Now, which means that if I am here today, then today, which is period 0, 0, 5 would be, so if I have a certain amount, let's say P, okay, using this expression here, I can tell how much P would be with this expression after 5 years. Okay, that's the concept here. So we can easily say that then to find the future value of a certain sum, then we can have this expression 1 plus I to the power N. Okay, if we have this here would give us the future sum. Now, if so, it means that we can call this P the present value or the present sum. Okay, present sum, and F would be future sum or future value. Okay, so this here is at the heart of many calculations in finance, okay, in mathematical stuff. So we say that we can express the time value of money in a form like this. That, for instance, if the purchasing power of money over a given period. You say, for example, if a ball of kinky this year is 1 cedi, do you think the same ball of kinky will go for 1 cedi next year? Now, even if the price still remains 1 cedi, the size will not remain the same. Now, in fact, the last time I had a shock, I went to buy kinky, and the last time I noticed, I remember that the ball of kinky was between 1 cedi and then 1 cedi 50 pesos. I went, and then the lady says, "Oh no, now there's no 1 cedi, there's only 2 cedi and 3 cedi." But even if you look at the size of the 2 cedi ball of kinky, there's no difference in what it used to be when it was 1 cedi. So this is a clear implication of what the time value of money tells us, that the value of a certain sum today will not be the same. Now, today, if you have 40,000 cedis, or let's say 60,000 cedis, and you want to buy, let's say, a Toyota Camry or Toyota Corolla 2016 model, and you don't buy it now, wait till, let's say, next year or next 2 years. That same car, the same model, the same specifications, you won't get it at that 60 or 59,000. Okay, so it tells you that money loses its value with time. What you can do with a certain sum of money today, over a certain period, you won't be able to do the same amount of money. So if you have the opportunity of making money, it is now. Once time passes over it, you would have missed the opportunity of making that money, because that same value of money would not do the exact same thing you do today. Again, go on to the market. So sometimes, because of these things I teach and these courses I do online, you would come to understand sometimes you need to be getting yourself abreast with stuff. 3 months ago, the bag of cement was 55 cedis. Today, if you go check on the bag of cement, it is 60 cedis. I can assure you by December, the bag of cement will probably get to 70 cedis. So if you have, let's say, 60 cedis today to invest in cement, and you do not buy it now, by December, these 60 cedis will no longer be able to buy a bag of cement for you. You would need to augment it to top up. So you would have probably lost value. Now, one other reason why we need to study also the time value of money is the issue of depreciation. Okay, so a machine or something would have lost its value or would have depreciated relative to efficiency or effectiveness over a certain time. Again, if you buy a car today at 50,000 and you use it for 3 years and you want to sell it, don't expect anyone to buy it for you at the same 50,000. That's why we have registration, so that we can know which year you bought it and when you registered it. Okay, so the idea is that if you buy a new car today and you use it over a certain time period, as a result of using it, its extent of efficiency and everything will not be the same. And so it would have depreciated. And I'm sure you will understand this concept of depreciation. Then the other part of it is, another thing is inflation. The rates, the changes that occur in prices of goods and services on the market. And so again, inflation, I am quite curious why it's always a concept that you never find it reducing. If it reduces, it's so marginal. Think about it. Has there ever been a time that fuel prices will significantly fall? Oftentimes, it is always increasing. Most of the time, so you will find that there are very rare moments that you find some marginal reductions in fuel prices and everything. But in the country in which we live, even if world prices are falling, we don't really see that same effect in the price of fuel here. So oftentimes these things turn out to be the the real issues or the predominant issues why we need to study the time value of money and get to understand the equivalent of a certain sum today or at a certain future period, so that these things help us to make decisions. Okay, so the relationship between the present and future sum of a single amount of money is expressed as this. Okay, so we have said that this expression here can help us find the value of a certain amount in the future. Okay, initially used to be n. Now, so this f here we refer to as the future sum, and this p here is the present sum or the present value. Okay, so if we want to find if this would help us find the future equivalent of a certain present sum, then if we toggle this around, it could also help us to find the present equivalent of a certain future sum. So this is like f equals p 1 plus I to the power n. This would tell us how much a certain sum will be in the future. So if I have 100 cedis at a certain interest rate over a certain time period, so I is the interest rate, n is the number, maybe years or months. This can tell us what with this expression, we can know what 100 cedis will become, let's say in 5 years or in 4 years. Now, so then I can also say, okay, so if I have, let's say 100 cedis, let's say today we are in 2021. So let's say in 2025, what would 100 cedis be? So it means today I have 100 cedis. I want to take it into 2025 and see that's 4 years. I can also say, okay, if I have 100 cedis in 2025, what would be its equivalent in 2021 now? So if that is the case, then we can find an expression. We just want P to start on its own. So this would be P equals F over 1 plus I to the power n. And this would tell us what the present equivalent of a certain future sum would be, okay? So the relationship between the present and the future value of a single sum is fully established here in this expression, okay? All right, so this is what we are saying. So if I have, let's say, this cash flow diagram, in year 1, there was an inflow of 2,000. In year 2, there's an inflow of 3,000. Maybe we are expecting, okay? Sometimes even times we do projects and we make certain estimations. We expect that this would be certain things that would happen. We can find the future equivalent. So we can say, if I'm here today, what would the value be at this point? Or if I'm here, what would the value come to be at period 0? So for the future amount of 3,000 cedis at period 2, it has to move back 2 periods to the present, which is period 0. Thus, n equals 2. Therefore, P naught, okay, so P at 0 would be this expressed. So it's like saying, if I'm here, I would have to move 1, 2. And that gives me the number of years. That is how we find n, okay? And if I was here, I would move only 1. So if I were here, let's say 3, you're going to move 1, 2, 3, and that's also. All right, so if I'm expecting these cash flow, 2,000 and 3,000 in years 1 and 2, I want to know how much this combined would be today. It is just saying take 2,000 over 1 plus 0 plus 0, assuming that the interest rate is 5%. This would give me this. So I take this, I bring it to period 0. I take this, I bring it to period 0. So this would be this 2,000 over 1 plus the interest rate times 1, which is the period, plus 3,000 divided by 1 plus the interest rate is 0.05 to the power 2. I break this down and then it gives me this expression. So in the future, these two values would be, in today, the equivalent of these two today is 4,625.85. In other words, you are indifferent between receiving 4,625 today and receiving 2,000 in year 1 and 3,000 in year 3. So this should be year 2. In year 2, if interest rate were to remain at 5% per year, okay? All right, so we can find the present value of these cash flows. Everyone can do it, right? So we can find the present value of the cash flow here, assuming that the interest rate is 10%. The interest rate is 10%. We can also represent this information on the cash flow diagram. In year 1, we have 2,000. In year 2, 5,000. In year 3, there was no cash flow, so we just leave it at that. In year 4, there was an outflow of 2,000. And then in year 5, we have this. So we want to bring all of these future sums, okay, to today and see what the equivalent would be. So we start from the first one, we bring here, okay, and 2,000 over 1 plus the interest is 10%, 0.1 to the power 1. And this is again an inflow, so we do for 5,000 plus here there was nothing. Actually, we could have just ignored it anyway, but we bring it in, and Then this was an outflow, so you have a negative 2,000, this, okay? Then plus the last period, it is an inflow again of 3,000, 3,000 over that, we discount it. So what we are doing here, we say we are discounting, okay, we are discounting the values, okay, or discounting the cash flows. So we do it, and so we're saying that with all these cash flows, expecting today, all these sums would be 6447.15, okay? So the present value of this cash flow is this. Perfect. All right, so now let's look at the types of cash flows. There are different types of cash flows that we have. Next type, we'll refer to it as the uniform cash flows. There are certain cash flows that come in, and then the amount coming in is fixed. Okay, it is the same amount that comes into. So take something like a salary. Suppose that your salary will not increase over a period. You have been paid 10,000 cedis every month for the next 3 years, and it's a contract. You are sure that every month, or probably every period, you are going to receive 10,000 cedis, 10,000, 10,000, 10,000. Again, look at it in the case of a loan deduction. That is an outflow. Now, if the bank says that all things being equal, the interest rate will not change, and so the same amount will be leaving your account every period, that same, every period, every period. So the idea is that constantly you're going to have a certain fixed sum leaving your account every time, okay? So in those instances where we have the cash flow to be the same, either going out or coming in, we have what we call a uniform cash flow. Now, when we have uniform cash flows, they could be quite many. Now, if we have seen, if you are asked to discount these uniform cash flows, if it is quite a few, maybe 5, 10, or maybe 20, it is okay, we can. But when these cash flows become so many, life will become quite cumbersome. Imagine that you are to receive 10,000 cedis every month for 5 years. Okay, for a year, that is 12. Another year, so that is 60. So if you are to discount all this, that means you're going to compute or do that discounting process 60 times. That is quite, what's it called, a bummer. It's going to be something that will be quite laborious to do or tedious. So like taking them one after the other, one after the other, one after the other. So look at it from this point of view. So suppose that I have a uniform cash flow. Sorry, I have a uniform cash flow as this. 1 to whatever number of periods. So let's call it up to period N. You would have to take this, you do A over 1 plus I to the power 1. This is period 1. And again, it comes to A 1 plus I to the power 2. Okay, then A 1 plus I to the power 3. Now, this A, we refer to it as annuity. Annuity means it's the same amount that is coming in over and over and over. Okay, so you notice that you have to do this 1, 1, 1, 1, 1, 1, 1 for all of them, and when you're done, you sum it all up. It's quite a challenge. So this is what we're trying to do. So we started doing it. So you start A 1, 2, 3, then we skip all the way to n minus 2, n minus 1, n. And I hope you remember I explained this to you what this n minus 2, n minus 1, and n means, right? Guys, do you remember? Hello? All right.
Yes, sir.
All right, sure.
Yes, sir.
So n is the last period, whatever period is it. Then the period before the last is n minus 1, and the period before the penultimate is n minus 1 in order. Okay, so actually we would have done all these to whatever number and then sum all of them. But let's see whether we can solve it using some algebra and then see whether we can come out with one formula. So once you have the information, you put this into the formula. 1, 2, you are done. You can just easily solve for it and you don't have any problem, okay? So given this expression, the one thing that is common to all of them is the A, the amount that we want, that will be coming in or going out every period, that uniform amount. So we can take A out. So P equals A. Then if I factor out A, everything here will be left with a coefficient of 1. So that's what we have here, 1 over this, 1 over that, 1 over that, all the way to n. So we kind of like assume this is equation 1. Okay, guys, just follow through. I don't need you to memorize this. I just need you to just see what we did. All right. Then to have this as equation 1, we try to form an equation 2 by saying, let's divide all of this, okay, we want to divide all of it by 1 plus I, okay? We'll divide equation 1, okay, by 1 plus I to have equation 2, okay? So we divided equation 1 by, so it's just like saying, think about it, if I take the first one and I have 1 over 1 plus I to the power 1, again, I divide by 1 plus I, okay? So this is the same as 1 over 1 plus I to the power 1, okay? Then it's like you're going to multiply it because this is division, you're going to multiply. This is all this one, so you're going to have 1 times, so 1 over 1 plus I. Okay, so this will give you 1 over 1 plus I squared, okay? So that's the exact same thing. So if this has 1 power, it will become 2. This will become 3. So that's what we have here, right? So this here, this one here, when you divide by this, it becomes this. When you divide this by this, it becomes that. You divide this by that, it becomes that. And it goes in that order until. And you see that the last one, which is n, will now become n plus 1. Okay, that's all we are saying. So we will refer to this as equation 2. Okay, so if we have this as equation 2, so please notice that what we have done here is to take P and divide by this. Okay, divide by stuff like that. So, all right, so now we want to now subtract equation 2 from equation 1. Okay, or is that it? Yes, so we want to subtract equation 1 from equation 2. All right, because equation 2 seems to be the bigger one. You see, equation 2 has powers of 2, 3, 4, 5 up to n plus 1. Equation 1 has 1, 2, 3, 4 in that order. Okay, so if we are going to subtract these two, now look at it from here. So they will look the same. Let me just try and see if I can. So you have, this is equation 2, this is equation 1. So let's take the first one. So you have 1 plus I to the power 1, right? Then like I'm trying to pass over everyone and their partner. This one goes to this one goes to this one goes to this in that order. So then you notice that this is going to be it's going to be minus 1 over 1 plus I to the power 2. You get it? Then when we move here, the next one, this one here is plus 1, okay? 1 plus I to the power 2. Then we'll move to this one here, minus 1 over, because this is the second one, 1 plus I to the power 3. It goes in that order. So you notice that 1 divided by 1 plus I to the power 1 doesn't have a partner. It doesn't look like anyone. But you see, this guy looks like this. This guy will look like this in that order. So you notice that 2 would cancel, 3 will cancel. So you notice that all those that are in between would go away. So 2 has a partner. So, okay, so 2 has a partner here because we're subtracting. This has a partner here. This has a partner here. Okay, whatever is in between them all has a partner. This guy has a partner. N has a partner. It is only left with this guy here, 1 over 1 plus I to n, and this that do not have a partner. Okay, so just think about it like that. So here you notice that because we did P, which is equation 1 minus equation 2, and this represents equation 2, which is P over 1, and the A is out, we are left with 1 over 1 plus I to the power 1, all divided by 1 plus I to the power n plus 1. Okay, this is like the stuff here. Now, we can start dealing with the issues one after the other, so we try to rearrange. These two share stuff, so I think we can factor out some stuff. If we factor out, let's say 1 plus I, okay, to the power 1, or let's even power 1 is the same as 1 plus I. If we factor out 1 plus I, you'll be left with 1 minus this to the power n, because you know this 1 and this 1 goes out. So you now have this and all that is left here, okay, as this. Then here we want to like make this guy look fine. This is like this one has like a denominator of 1, right? So if this guy has a denominator of 1, we can use the LCM approach. Okay, so if you have the LCM stuff, everything divided by 1 plus I, you will have something that looks like this. So you have this whole expression be equal to this expression. Then I think the other thing we do is to probably redistribute all this. Like this is equal to, so we can let this multiply everything here, and this also multiply everything here, and then cancel out a few stuff. So we get through it in a certain way, and at the end of the day, we arrive at this expression here. Okay, I'm not really interested in the math for you. So guys, this is, if you want to find the present value for a uniform cash flow, you want to find, this is the only thing we need. All these other things do not really have any bearing on what we are doing here today. So if you want to find the present value of a uniform cash flow, we say it is the annuity over the interest, okay? All into bracket 1 plus the interest to the power n minus 1. Please bear in mind this minus 1 is not the n minus 1. It is everything here minus 1, okay? All divided by 1 plus I to the power n. Okay, so this would give you the present value for annuity. So for a uniform cash flow, this expression here is what we use to find the present value. Okay. Now, if we substitute this formula into this future value, we say that the relationship between the present and the future value are found in this. So if you want to find the future value of a certain uniform cash flow, then we apply this formula. F equals P 1 plus I to the power n. But we have said that P, okay, we have found all of this to be P, okay? So we are kind of like saying we are representing the whole of P to be A over I, okay, 1 plus I to the power n minus 1 over 1 plus I to the power n. Then so all of this is P. Then what is left is I plus I to the power n. Okay, so we kind of like cancel out this one. Again, not really interested. So for the future value, you are left with just this. The future value of a uniform cash flow is F A over I 1 plus I to the power n minus 1. So this here helps us to also find the future value for uniform cash flow. So please have this at the back of your mind. So oftentimes in exams, you would have this formulas given to you. So the present value for a uniform cash flow is A over I, 1 plus I to the power n, everything minus 1, divided by 1 plus I to the power n. And then the future value for a uniform cash flow is this, which is A over I, 1 plus I to the power n minus 1. Okay, this is the expression. Just have that at the back of your minds. So we are saying that, so let's take an example. Suppose that we have, for example, we test the power of the shortcut. So it's kind of like, let's see whether it works. So we have 5,000 CDs coming into our stuff. So this is from today, and then from year 1, year 2, year 3, year 4 to year 5. So which means that the money is coming in, it's being paid at the end of the period. The interest rate is 5. Now, if you were doing this individually, you take 5,000, do it over this, so do it 5 times, and we have this value. Okay. Now, if we are to put it into the same formula, then A, we said that the formula is the present value. Okay, the present value for uniform cash flow is A over I, 1 plus I to the power n, all minus 1 over 1 plus I to the power n, and close the bracket. A is that uniform amount, that's what we call it annuity. A is that uniform amount, which we represent as 5,000 here. It's 5,000 that keeps coming every month, over the interest, which is 0.05, okay? Then we open our parentheses, Let me say 1 plus 0.05 to the power, how many years are we looking at? 6 years. All minus 1. All over 1 plus 0.05 to the power 6. Once we do this, we have the same amount as this. So the shortcut works, okay, when we apply it here. So rather than doing this 5 times, you can just do this only once and you have the same stuff. That's the beauty about math, okay? So we have been able to, or we have all been able to come out with our own formula to kind of like get this thing done. Are we okay? So if you have, even when the period is 60, when it is 70, whatever number, you can just substitute this expression and then it will give you what the present equivalent will be. Okay, now, so let's look at the example. It says, the government of Ghana is to receive an amount of 10,000 for the next 100 years. Can you imagine? 100 years. If the interest rate is assumed to remain at 10% per year throughout the 100 years, find the net present value for all the cash flows. So imagine you're supposed to do this 100 times. That would be barbaric, okay? So, but once we can remember this expression, we take the 100,000, divide by the interest rate, which is 0.02, okay? And do 1 plus 0.02 to the power 100 minus 1 and all that. We can tell what that present equivalent today, what this would be. So the government of Ghana can go for a loan of 430, 980 something Ghana cedi at an interest rate of 10%, which they should be guaranteed will stay like this for this. And then once they collect all their 10,000 for the 100 years, they can pay for the loan at the end of the 100 years. That's like the situation. All right. So let's look at a situation like this. So there's a caveat. There's a little problem with this. So I need you to understand this, okay? Now, when you apply this formula, okay, when you apply the A over I, 1 plus I to the power n minus 1, all over 1 plus I to the power n, when you apply this, it takes you to the period immediately preceding the beginning of the cash flow. Please let me say it again. When you apply this expression, when you apply this formula, the net present value for the uniform cash flow formula, it brings you to the period that immediately precedes the beginning of the cash flow. So, for instance, when we had Julius, you have a question. Yes, please go ahead, Julius. There's no time. Hurry up. Ask your question.
Like the question that you just shared on the screen, I saw the interest rate to be 10%, but when you were trying to solve, I saw some 2%. I don't know where the 2%.
Since the interest rate is 10%. Oh, okay. So I guess the issue changed. Sorry. It's supposed to be 10%. So this is a typographical error. So please, then let me make it 2% here so that will be consistent. Okay. So we were so here it's supposed to be 0.10. Okay. But I think when we were summarizing, we wrote 2%. It happens. It's a mistake. Okay. Thank you so much. Right. All right. So now, if you're using this expression here, we're saying that it takes you exactly to the period immediately before the beginning of the cash flow. So here, let's look at this case. Our cash flow started from 1. The period that immediately begins the cash flow, or that comes before the cash flow, is 0. So here we are safe. It means that it will lump everything together like this and bring it to here, to 0. Okay, but now let's look at another example. Now look at this. Here we have this, it starts from year 3. So which means that when we apply our formula, it will bring us here to period 2. Are we okay? So there should be a way in which we should also be able to solve this. Now, the idea is that when we take this formula and you bundle all this and it gives you the present value, it gives you the present value and leaves you at year 2. But it puts all together to give you one value, one composite figure. So given that one single value, you can take that one single value and bring it to year 0 using the formula that we have already known, which is the f over 1 plus I to the power n. Okay, so here you look at it from this perspective. You see, first we find the present value of the uniform cash flow in period 2. So here we'll substitute everything here. Okay, so here you notice that it's from 1, it's from 3 years because we move from this period. Now, please bear in mind that from here to here is 1 period, here to here is another period, here to here is another period. This is the end of period 2. This is the period 3, sorry, and period 4, period 5. So bear in mind, so that's why we have 3 here. Okay, so we use this and we compute this value, and we have I think 13616.20, but 13616.20 would bring us here, which is 13616.20. So now this is one single figure. So we can take this single figure and bring it to period 0. So here we'll take this one here. So it brings us to year 2 here now. So we'll now take it 13616.20 over 1 plus 0.05 to the power 2, and it brings us. So in today's terms, at period 0, these cash flows 5,000, 5,000, 5,000 is equivalent to what's it called? 12,350.33. Please, do you understand? Do we all understand this? Hello?
Yes, please.
Okay. So for this one, it is very easy. They are just 3. So you can even use just this formula alone and do it. And do it from 3 to 4 to 5. But if they are many, then all you need to do is apply this expression. It brings you to the period that starts just before the beginning of the cash flow. Just have that at the back of your mind. If you use this formula, it brings you to the period that precedes or that starts just, or the period that comes just before the beginning of the cash flow. So the cash flow begins at period 3. The period that comes before it is 2. So if we use the formula, it will bring us to period 2. But it brings everything together as one value. So once we have one value, we just need to apply this expression and it takes us to 0. Okay? All right. So it says that you borrow 10,000 from EcoBank at an interest of 10%. Okay, to be repaid in 5 years. What is the equal amount to be paid, to be saved each year in order to repay the loan in full? So guys, now this is another dilemma. Okay, now think about it. Today, now you see, so because this is math, don't always think that the question is always going to be like, okay, so we give you the future value and then find the present value. Now, here we have given you, say you have borrowed a certain sum, 10,000. So you have borrowed 10,000 cedis. This is the amount you have borrowed today, isn't it? Now, so having borrowed 10,000 at a certain rate, and you're supposed to pay in 5 years. So here you have been given the P, you have been given the interest, you have been given the N. You have been asked to find A. Okay, so the smartest thing to do is to just substitute all these. Well, of course, we have tried to like carve out the formula by doing the change of subject, but guys, look, if your math doesn't work for you that much, don't struggle with these things, trying to just substitute the values in it. You see, when you are dealing with actual figures, you will see that life works out very easy. Think about it this way. We say you have borrowed 10,000, so we know that 10,000 is P, okay? We don't know A, but we know I. I is 0.05. So now you know 1 plus 0.05 to the power 5 minus 1 all over 0.05 1 to the power 5. I can assure you, you can deal with everything that is inside here, isn't it, and get one composite value. And still deal with A over 0.05, they multiply by whatever you have here, okay, times 10,000 here. When you are done, you multiply it through, and this you just divide both sides by whatever this value is, and then you can find your E. Yes, Julius, you have a hand raised.
Right, sir. The question you are solving, is it supposed to be 0.1 or 0.05?
It's supposed to be 0. Why do I keep making this mistake? It's 10%, isn't it? So it's supposed to, but you are seeing it is 0.1. Yeah, so I don't know. My mouth is going faster than what the solution is. Sorry. It's supposed to be 10%. Okay. So please take the interest rate. Forgive me. I guess I ended up my lips are going faster than what I'm supposed to be writing. All right. So here it is easy. Just substitute what you have into the expression, solve for it. Whatever you need will come out on itself. Okay. However, if you want a formula for this, then the idea is that we would have this A equals P times I. Okay. P times I. Sorry, you don't even need to. A equals P times I times 1 plus I to the power n all over. We divide everything over 1 plus I to the power n minus 1. Okay. So you have, but oftentimes when you have too many formulas to grapple with, it makes things very confusing. Okay, so for me, oftentimes what I just advise my students is, once you understand the question, just substitute the values into it themselves. Once you are dealing with numbers, the values themselves will come out. You notice that when you deal with everything in this bracket here, you have one single value, maybe 0.00011 or something. And maybe A is what we're doing, but this is 0.05. Okay, then we also know P to be maybe 100. Now at this point, you know that you can divide both sides by, you can multiply through by 0.05. I hope you get it. So once you, just to get rid of this, so I can multiply this by 0.05 and multiply all of this by 0.05. So 0.05, this will cancel. And I multiply this one by 0.05. So you have this. So whatever is left here, maybe 0.05 of 100 is 5, right? If you were, so 5 equals A times 0.000 something. You divide both sides by this value, you find what A is. Life is simple. But if you are the type that can easily cram formulas or can easily handle formulas, then this is the formula for finding A. Otherwise, please, just all you need is this formula. And whatever you need, just substitute whatever you need, solve for it, and you get your answer. Okay. So we are saying here that this A here is that uniform amount that you are going to be paying for the next 5 years at an interest of 10% to pay the loan of, what's it called, 10,000. Okay. All right. So when you are going for a loan, and these people tell you that, oh, for this loan, okay, we can even give you the loan for 36 months. Okay. Normally, when it is when you are going for a loan for, let's say, 2 years is 24 months, they'll be charging everything monthly. And then, okay, so Clement Opoku, you have your hand raised. Please go ahead. Clement, please hurry up. Okay, Clement will ask his question when he's.
The A is what?
The A is that annual amount. Okay, that amount you're going to be paying all the time. In other words, we call it annuity. Okay.
Okay, please.
Come again.
I said okay.
Oh, okay. All right, sure. All right. So so in this case, the question is interested in us finding that equal amount, and then the equal amount is A. So we can be able to find it. All right. So someone should give me what's it called? An idea of how we'll solve this question using what we have spoken about so far. Okay. All right. So tell me, how do we solve this question? Look, I'm not asking for the solution. You see, so it starts with a certain inflow of 2,000 for the first 3 years. Then it shoots up to 7,000. Then it shoots up to, then it shoots down to 4,000. Tell me, how do we go about it? I want like a framework. Someone should give me a framework how we go about it. Let me see. The first person to give me a correct or a good framework would have something. Yeah. So I'm waiting. Anyone? Hey, So no one is willing to volunteer. Okay, all right. So think about it here. We have said that when you apply, all right, when you apply the formula, okay, that it takes you to the period that immediately precedes the beginning of the cash flow. Okay, it takes you to the period that immediately precedes the beginning of the cash flow. So you can take the first three, which is 2,000, apply the formula, and it will bring you to 0. So that one is sorted. So you keep it down. Then, if you like, you can deal with this 7,000 alone and take it to 0 and also hold it down. So we have brought 2,000 and 7,000 all to 0. Then you can take again these 4,000, apply the formula. It will bring you to year 4, okay? And then again, take that single figure at year 4 and bring it to 0. And then sum all the values that you have brought to year 0. Or one thing is, take these 3, bring it to year 0, and let's keep it there and wait. Then take these 4,000 here, okay? Apply the formula and bring it to this point. Whatever it gives you, add it to 7,000 and take it as a single value and bring it to 0. Either way, it still works. So this is what we did. So we say that we took from 0 or from 3 to 0. So we took this one. Okay, and so when we take all the 2,000s and take it to 0, we have this value. Okay, then we took the 4,000s. Okay, we took the 4,000s, right? And we did up to year 4 because this is it starts from 1, 2, 3, 4, or year 1, 2, 3, 4. All right, so we take the 4,000s and we bring it to this point and it gives us this value. Okay. Now we have 1418 stop. Okay, but there is 7,000 here. Okay, there is 7,000 here. So we add 7,000 to this value here. We add 7,000 to this value here. Okay, we add 7,000 to this, and we end up having 21,183.8. Okay, and then we take that single value here at 21,183.8 and take it from year 4 to 0. Okay, so we'll now end up having this. So at the end of the day, we have brought this value to 0. We have also brought this value to 0. So we'll now add this and this like we have done. This one plus this one. And then we'll end up having this value here. 22,694.46. That becomes that. So you kind of like have to think about how to manage the procedure and then come up with the solution that works. It's fine. Please, how much time do we have? Okay. So we can move to the next type of cash flow. Next type
Time is up.
The time is up.
His time is up.
Negative 2.
So it's time.
The time is negative 2.
Do you have another class at the moment?
You need time to go
Yes,
and
sir.
review.
Yes.
You have a
Yes.
class. Yes, please.